Would like to welcome students in Math 1108, starting in Chapter 2 work. I'm Professor Paulin. We follow a certain protocol. Today we're going to do Learn Lesson 2.1. When we're in a Zoom mode, we would have a waiting room and chat with students, but what you're going to be doing is in a notebook similar to this. You're going to be taking notes on the Learn, and we want to feature the title, and then as we do the lecture notes, you put them there carefully, and then in some detail, write out that particular lesson. If you have a question, put a little question mark by it. Then in class, we do a classwork notebook practice where part of the program of the software Hawks is a practice. I made copies of some of the examples, and then as our classwork, we'll be doing this, and you'll be writing these in as part of our class. So, with that brief introduction, we'll get started on Learn 2.1. So in your flipped classroom notebook, on that first page, you're going to put the title, Lesson 2.1, Solving One-Step Linear Equations. And this is right from the Hawks software program. The second booklet that we use is Practice, right there. And then you'll also be working on your own to do the Certify, which gives you points toward your end of term grade. Generally, at the beginning of every Learn, they give you the objectives that we're going to be going over. And here we see two forms of the linear equation. And it shows, we want you to write this down here. This is the standard form. This one first. X plus B equals C. And then another form, AX equals C. Now, these are called linear because the variable that we're using to solve is only to the first power. We don't write the 1, the exponent 1. And in a sense, they would be linear, a line, if we were to do some graphing, which we'll do in Chapter 3. Now, before we leave this page, I'd like to feature this teeter board or balance of some type, where we have a fulcrum, and then on this side we have something that is the same as we have on this side, and the fulcrum, the balance, balances. In a sense, we think of these values of being equal. And this way we can hopefully visualize what an equation is like. Now, we're presented with an equation, and how do we get to solve it? Well, it's through a series of steps where if we remove something from this side, it doesn't balance. But if we remove that same thing from the other side, it's not the same as it was originally, but it still is equal, it balances. And if I remove something else from this side, now it won't balance, but if I remove that same thing from the other side, it will. So what do we have then? Well, we have, let's say, left in an equation on this side the letter x, and then on this other side a number 3. So we say then that this unknown, because everything else has been taken away, is equal to 3. And the series of steps that we do, remember, whatever we do to one side, we do to the other through a series of mathematical processes, and we end up with a value for x. So x then equals 3, and we have solved that equation. And that's what we'll be looking at as we do these. So in this next slide, they're talking about solving one-step linear equations, and there are two standard forms. And sometimes they could be a little more complex than this. But what we do when we go to solve and we have a solution to check it, we put that known value now replacing the unknown. We did some like this earlier, and then see if in fact it does make both sides equal. Now, throughout your flipped classroom lecture booklet, notebook, where you take notes, I do want you to write out these examples that we do in some detail. So you're going to put in your notebook, example 1, and then letter A, and you're going to write this. So x plus 5 equals a negative 2, and then we're saying that x equals a negative 7. So as we do that, we're going to replace the x here with the negative 7. So negative 7 plus 5, does that equal a negative 2? Well, when we do this, we end up with a negative 2 on this side equals negative 2 on this side. So we put like a little check and we say then this is a solution for this particular equation. Now, rather than my writing these out, I will follow what's in the slide here, and you are just to copy it into your notes. So I'll clear this up, and you're going to now put letter B and copy this down. And then you're going to put in there a negative 1.1. Now, fortunately, in these slides that we're using, they have it worked out as a replacement. So when we do so, we end up with the answer. Take some time, pause the video if needed, and you get as a 0.3 does not equal 0.5. So in this case, the negative 1.1 is not a solution, and it doesn't check. Now for letter C, again, you're going to copy this down. Then underneath it, you're going to put the replacement value of 2.7. Now, when you actually do it, it does check, and it makes it a true statement. So in letter C, this is a true, or it does make one. This one was false. This one was true. Now for letter D, and I'll write this one out here. It says Z, absolute value of Z minus 14 equals a negative 3. So they're going to replace the Z with a negative 10. So negative 10. Now what's the absolute value of negative 10? Always the positive. So this will be 10 minus 14. Does that equal a negative 3? Well, this is a negative 4, and that's a negative 3, so it does not equal. So it is not a solution. All right, that's example 1. So going on in your notebook, you're now going to put example 2, and we'd like you to highlight that. And I'll write it out big for you, and this is what you should have in your notes. So we have a rather simple example where basically what you want to do on one side is isolate to get to the x all by itself, and then a number on the other side. So going into our toolkit, what can we add to a negative 3 to make it 0? Well, that would be the additive inverse. What is the additive inverse of a negative 3? Well, a positive 3. And the rule is if you do something to one side, you must do it to the other side. So here the 3's add out and we end up with just an x left on this side and then a 10. X equals 10, and that is the protocol for solving a simple equation like this. Now notice the way they're showing us in the textbook is they're doing it horizontally. I tend to like it vertically, and you can do it either way. That would be perfectly okay. Let's go on. Again, you're going to write example 3, and then you've copied the example down. Be sure you copy it correctly. Never hurts to take that little extra time to check. And we could use a whiteboard here too. So there's our equation. Now notice the y is on the right, not a problem. We still want to, again, try to keep our equal signs lined up. What can we add to a positive 5 to make it 0? Well, a negative 5. If we do it to that side, we must do it to this side. So again, these cancel out. We're just left with a y. And this is a negative 16. Again, we're doing some very easy ones to start off with, and they show us the horizontal way of doing it. Let's go on. In your notes, example 4, and there's the equation. I've put it a little bit bigger, and we're going to go to the whiteboard. And again, you might say, oh, this is strange because we're having all of this equals 0. Not a problem. Again, we're going to use the additive inverse, plus 4.1 to both sides. Here, this adds out. We end up with x, and this is 4.1. And we check it out, and that is correct. Example 5, and I've copied it. We'll go to the whiteboard. Now, here's a case where we have fractions. And there is a protocol to get rid of fractions. And I want to change colors to show you this. And that protocol would be put a set of brackets on either side of the equation. Now this is a term, this is a term, and this is a term. What do we do to get rid of these fractions? Well, we're going to multiply each term by something that will cause these fractions to cancel out, these denominators. And we have all our denominators just become a 1. So what is our least common denominator as we look at this? Well, again, some of you may need work on this, but it happens to be a 10. So if I multiply each term by this 10, I'm going to get rid of my fractions, and I'll show you the process. Now, keep in mind this is over 1. We just don't write it. So there's nothing to cancel out there. That's already a 1. So 10 times x is 10x. But now it's 10 times this fraction. It's going to be a negative. But I can do some canceling. 5 will go into there once. 5 will go into 10 twice. So I have 2 times a negative 2, which is negative 4. Oh. And then here, 10 will go into 10 once. This will just become a 1 here. 1 times 3 is 3. So by using this simple process, I've gotten rid of all my fractions, and I have a much easier job working with an equation without fractions. So we're going to use that same technique. I'll go back to red now. I want to isolate the x term. So how do I get rid of that negative 4? Well, I add 4 here, and I add 4 there. So I now get 10x equals 7. Now here I have 10 times x. How do I get rid of the 10? Well, since 10 is a factor, and x is a factor, if I divide this side, and this is the numerical coefficient of x, by 10, what I do to one side, I do to the other. Here the 10s cancel out, and I get x now equals 7/10. And let's take a look. X equals 7/10. Now for example 6, and I'll go to the whiteboard. One of the things we do is look at the equation first after checking that we've copied it correctly. Is there something we can do to simplify? And the answer is yes. We can combine like terms. Well, here are two like terms, which will end up as being 1z plus 2. And these are like terms. That would become 11. So again, we've simplified what they've given us by combining like terms. Now, generally we don't write the 1, but it's okay when you're computing to write the 1. But in an answer, you would, if it's just z, you don't put the 1. Now, how do I get rid of the 2 again? Well, I'm going to use its additive inverse, minus 2, from both sides. So I end up now with just a z left. I'm not going to write the 1. And I end up with a 9. And that is this one as we go back and check it out. Now again, they're doing it horizontally, but they are combining like terms. Now, for example 7, they're mentioning that we are to simplify before we move on and then solve it. So we'll go to the whiteboard, and as we look at the equation, we say, what can we do to simplify? Well, we can combine like terms here. So this is going to be 1x left minus 1.5. And then we can combine this into 10.3. So what do we do to get our solution? Well, we're going to add the additive inverse of a negative 1.5, which is a positive 1.5 to both sides. This side, this cancels out. We end up with an x. We don't write the 1. And here we get 11.8. And as we go back, we see that is the answer. As background, we went over this form where the x is not with a 1 that many of the others had, but with some other number, such as 5 or a fraction 1/2, and we want to isolate the x. So here we're going to use that technique of dividing by whatever a is, both sides. That's the numerical coefficient, and we get our value that way. All right, so let's go on and take a look at this. So again, you're going to write example 8. Copy this down, 5x equals 20, and we're just going to divide by 5, the numerical coefficient, and we get x equals 4. In example 9 that you're going to include in your notes, we'll go to the whiteboard. This is what you want to write down. And again, you want to check that you've copied it carefully. We can do some grouping of like terms here. This will become a 1.3x when I add these together. And this is, we're going to subtract this. This is going to give me a 9.1 when I do this subtraction. And I divide now by the numerical coefficient of the x, 1.3, both sides. And I then get a 1x, I don't write the 1, and this is 7. We'll check our work, and it looks good. Again, example 10, a negative x equals 4. Now there's a shortcut to this that I'll tell you in just a moment, but remember there's a 1 there that we don't write. But if we want this to become a positive x, we can divide this side by a negative 1, this side by a negative 1, then this side becomes a positive x, and this side becomes a negative 4. Now the shortcut way of doing this is if you see something like this, just reverse the sides. This side becomes a positive x, this side becomes a negative 4. That's the shortcut. This is the protocol that allows you to use that shortcut. Now, for example 11, and you're writing that out, we'll go to the whiteboard. And this is sort of a special case. Now, when we see a fraction, and this can be written like this also, 4/5 x equals 3/10. And we want to get rid of that fraction, and it's a factor. What can we always multiply a fraction by to make it a 1? And I'll change colors. And if you said reciprocal, that's something you might remember. What's the reciprocal of a number? Well, it's what you multiply it by to make it a positive 1. So what is the reciprocal? Well, it's just the flipping of your fraction. So it becomes 5/4 on this side. So the reciprocal of 4/5 is 5/4, because if you multiply it, everything cancels out and you're just left with a 1 here. But remember, if you did something to one side, you must do it to the other. Now here we can do a little bit of canceling. 5 will go into there once, 5 will go into there twice. So we can't do any more canceling, so our numerators become 3. Our denominator is 8. So the answer to this one, and we don't write the 1, x is 3/8. And we use another little technique here. Now we're almost finished. This is example 12. And let's read it together. The original price of a Blu-ray player was reduced by this much. The sales price was this. Solve the equation. They're now putting it in algebra form to determine the original price of the Blu-ray player. Well, there's our equation. You can follow along here and write this out. The additive inverse of this, and we put it underneath usually, 45/50, 45/50, and it's pretty simple. Add them up and we get the original price was $211.40. So for the students in the 1108, this is our first lesson in Chapter 2. We'll do some others, and generally we're going to follow that same protocol. You do the flipped classroom lesson to learn before you come to class.